All right, guys. So some last thoughts on this uniform distributions. What I'm about to tell you is going to be in the homework. That's about it. But going back to that bus problem. What do you think the average amount of time somebody waits is? Yeah. So in general, this is A and this is B. The average is just the average of the endpoints. Hopefully that makes sense. They're all equally the same, so the average is going to be whatever's in the middle. Did you guys hear what I said earlier about this won't be on a test or something, but it will be in the homework. You still have to do it. They're just formulas to plug shit into. Right? This is the one that one semester I brought in the proof of this formula because everybody always says, where the shit does 12 come from? So if you want to see the calculus behind this formula, you either come see me or I can bring it in if you guys want to see it. We'll see why. You don't have to have had calculus to take this class, but one thing calculus does. One thing it does is it tells us how to find the area under anything. Not just the square. It could be some freaky ass looking thing. If I have the function for it, I can find the area under it. Right? So calculus is involved in this type of thing. So again, if you want to see. So these are the formulas for the mean and the standard deviation for a uniform distribution. You'll have to use them in the homework. So what if it was 7 to 35 like we had earlier? Well, then you just put a 35 and a 7 in, 35 and a 7 in, and figure them out, right? They're just plug and chug.
So it's always 12.
This is always 12. Same way this is always 2, really, right? Nobody has any problem with 2, but they're always like, why 12? Why 2? Okay. So we understand it. You still have to do the freaking homework, but it's just plug shit in. This isn't really used very often, to be honest, but it's there, it exists. And what did I say? Any distribution we give, what 2 things do we want to know how to get? The mean and standard deviation. So there you go. So chapter 5 kind of is the groundwork for general ideas of continuous distributions. Chapter 6 is the most important section, the most important chapter in the book. So we're going to get in there now. Oh shit, no pressure, Jeff. Chapter 6 deals with normal distributions. So just to give you an idea of why I need a chart to look up probabilities. What does a normal distribution look like? Bless you. Let's just do an example where the mean is 10, the standard deviation is 1. It's a normal distribution. Can you guys give me a rough sketch of that? Okay, now do it on your paper. Dude, sorry, that would be weird. Or don't. You can sit there. At least draw a duck or something. Make it look like you're doing. Or continue staring at me, wondering what's coming out of my mouth. Okay, most of you guys are doing something. So, of course, the 10 and the 1 aren't really that important, to be honest, but where should the 10 go? I mean, here's the shape, right? That's the shape. Where's the 10 go? Right in the friggin' middle. And the 1 doesn't even have to really show up yet. You could start doing this. This would be like 11, this would be 9, right? What do these underneath mean? Yeah, how many standard deviation away? So I'll go one step up, one step down. Why are these nice numbers? Because the mean in the standard deviation was nice. Just being nice for right now. Don't get used to it. So if I wanted to know what's the probability that something is, that I get something between 9 and 11, you actually should know that, but we don't calculate it. We just sort of memorize it. Maybe. Who knows what that? Yeah. 68%, yeah. But do you see how, could you actually calculate the area of this freaking bullet shape here in the middle or whatever? You guys see what I'm saying? Here, this. Oh, I can calculate the area of that rectangle. What's the shape? What's the shape? A souffle before it's fallen? I don't know. Right? What's the souffle formula? I always have somebody who's like, why is he talking about souffles? You know what a souffle is? Yes. And if you're not careful, it drops. But so this one of my point is there a geometric formula for the area under this freaky ass curvy thing? No. There is not a standard formula for that. So we're going to need some help. Do you guys understand? Do I need help with finding that area? Oh, hell no. And if you do, get out of here. Do I need help? Yes. I don't know what this shit. That's not even a trapezoid or, you know, trapezoids are basically kind of freaky. This is even way freakier than that. All right, Jeff, I think you made a point. So this is 68%. So, but what if I wanted to know, somebody can help me out a little bit here. What if I wanted to know the probability that it was from, let's say, oh, my purple's dying too. Oh, there you go. Okay. Probability that it's 8.15 up to 10.92. So 8.15 up to 10.92. I want to know this area. We currently cannot do that. And in order to do it the way we did with this, I'd have to find the area of that, and we don't have any geometric formulas that do that. And in fact, let me do this. I want to at least make you look at this once. It's a very strange way to phrase that, Jeff. But I want to show you the formula for that shape. Just to show you it exists. You only have to look at it once. Again, you don't have to know calculus, but for those of you that do, you would just do the integral of this formula I'm going to show you. If you don't have a clue what I just said, you're fine. You don't have to know any calculus. For those of you with a book, it's like on the second page of chapter 6. Better. How you doing there, projector? Oh, okay, Jeff. Can somebody do the one that says whiteboard? Or maybe even the one next to it. Alright, cool. So I want to show you this once, just because it's fun to watch the reaction. There it is. Holy scheisse. Anybody notice anything? I mean, what's that symbol? Sigma, what's that? Pi. X is and what's that right in there? What's x minus the mu divided by standard deviation? What is that the formula for? Z-score. Isn't that kick ass? So actually, if you put 1 in for sigma and you put 10 in for mu everywhere into your y1 in your calculator and graphed it, it would come up with a normal curve. That's what the graph of this function would be. We're never going to use this function directly in this class. If you take more advanced probability that requires calculus, then maybe you would. Let me leave this on. I'm going to need this later. Oh, well, if you're at home, it's around page 342. Can you bring the lights back? Thanks, everybody back there. Or, okay. Thank you. Okay, so we need help. We need calculus. We don't know calculus. So let's go say, hey, calculus people, make a table of a lot of values for me so I can just look this shit up, right? So here it is. Here's the table. Let me give it to you. You're going to bring this table with you to every test from now on. You're not going to write any notes on this table. You with me? So be careful. Okay. Oh, before I forget, you'll all be very excited to note that we're going to have a quiz tomorrow. Chapter 4. Somebody remind me, when's our next test? When do I have that set on this homework sheet? So what is it? Tuesday. So I don't want to give it to you like I did last time. I want to have a day in between before. I'm trying to remember why I wanted it tomorrow. I don't want to give it back to you. I don't want you to take it Monday and then give it back to me next day. So it'll be tomorrow, and then tomorrow I'll also have the practice test to give you guys. Okay. And again, just to remind you, you're in an intercession class. You signed up for it, so I don't want to hear it. Yes? Yeah, those are the ones that were chapter 4. I never give a practice quiz except for the one double quiz. Quizzes are quizzes. They're just straight from the homework. Okay. So let's do, first thing is, how the shit do you read this thing? Alright? So everybody got one? Everybody has one? Okay. I'm sorry back there. I didn't know it was going to be so quick that I was going to do this. Okay. So let's first off, so any z-score, notice how slow I'm talking, so that's normally a good note. Any z-score you look up in the chart, it will tell you the area below that z-score, period. So let's see if we can be a little creative here. Don't worry about the lights. Leave them alone. So help me out here. What percentage is in here again for a normal curve? 68. So what percentage is outside? Yeah, 32%, right? So what percentage is on this side? 16. So what that means is, if I look up a z-score of -1 in the chart, it better give me a number that's at least rounds to 16. This chart, whatever z-score I look up, it will tell me the area below that z-score I just looked up. That's what this chart's job is. They had calculus, they actually had a computer just crank out the freaking numbers, but it calculated the areas, because it's not just rectangles, I need help. So this is the help we get. So watch how this works. I want to look up -1.00, right? I don't want -1.01. I want -1, Jeff, go to negative. So there's a negative side. Negative 1.0. These are the second decimal places. Negative 1.00. Can you guys all find that? So we're on the negative side. Maybe I should record this part. There you go, Jeff. There you go. You guys. Okay. And what is that? What's that round to be? 16%, right? So the empirical rule is kind of like rounded to a whole percentage, just to make it easier to remember. You guys sort of with me here? A little bit? So, okay. If I look up, what do I get if I look up 1.00? You guys look that up for me. So here we got 0.1587. If you look at 1.00, you get, what are you getting? Yeah. So if you look at 1.00, 0.8413. Okay. So how do I find the area right there? If that's 84.13% and below this is 15.87, how do I find the area in the middle? Subtract them. Does that make physical sense? This goes too far. If I could chop it off right there, chop that much off, it would tell me the area in between. And what is 0.8413 minus 0.1587? .6826. And what was it supposed to be? 68%. All right, so the empirical rule is rounded, but it just does that to make it easier to remember. But the first thing I like to do with this is show you how to read it and then recapture some stuff we know should be true. If this couldn't give me that number, then screw this chart, right? Too bad for you, I didn't make a mistake, so we're not going to screw the chart. We're going to use it. It's your chart to do with it what you want. Okay, so let's try a few more examples. Let me try to do this up here so I'm not like on the board part of the time. Sorry, little dude. Yeah. Okay, so let's try this together. And then remarkably enough, I got a handout for you to work on. So what if I want the probability that Z is less than 2.18? So a really good idea is to draw the picture. What's right in the middle for z-scores? Mean. 0, right? Because what's the mean always become? Because what's the z-score tell you? The distance from the mean in standard deviations, right? So how far away is the mean from itself? 0. So for z-scores, the middle is 0, always. Where's 2.18? Up or down? I love my people that just don't even realize this is a scale of numbers. You can't just put shit wherever you want to. It's up here somewhere, right? And where's the area that this is asking me for when you shade it in? Where is it? Yeah, less than. So that way. It's an arrow. Remember that from inequalities? It's an arrow going that way. Good. All right. Some of you guys are going to skip this kind of step, and you're going to make really simple mistakes. And maybe you'll learn from it, but maybe not. I don't know. So can you guys find this area? So let's all do this. This is the first real thing we've got. So 2.1. You guys see 2.1? 8. 2.1, 8. 2.1. Oh, that's hard to do up there. 2.18. There you go. 2.18. You guys get that? 9854. How's everybody doing? Yeah, it's almost 3. Be careful now. Yeah. When you do empirical rule, it's between 2 z-scores. This is strictly all the area below a z-score. So you can't really compare it to the empirical rule. So this comes out, shit, I forgot, what was it? 9854, right? One thing I want you to realize, what am I so far always writing on top? What is this? What is this?
Area.
I love it. That's an area which is equivalent to a percentage, which is equivalent to a probability. You guys with me? That was the whole thing earlier about the dartboard and all that kind of shit. Here's the visual representation. The whole thing is 1. That's the area. That's the probability. So if I changed everybody's height to z-scores, and I had somebody with a 2.18 z-score, then that means 98.5% of the people are shorter than that person. Is that cool? It's just stupid powerful, right? If I know something's normal, that chart is all the answers, just waiting to be found. That's why a huge part of statistics is, when is something normal enough? So I can use, because I got all the answers just sitting there like, I'm here waiting for you. I'm like, I don't know if this is normal, and this, it's too bad. So if I know it's normal enough, then I can use a chart. So there's going to be several times where we're like, I got to check, there's a test, if it's normal enough. If it is, yay, I can do shit. If it ain't, too bad. That would be stats 2. Yes?
Do we ever try to figure out something that's good, right?
Totally. So I'm building. All right, you ready? This is perfect. I planted Cassie out there to ask this question. So what if I ask you, what is the probability that z is greater than negative 0.91? What do you think the first thing is I'm going to suggest? Holy shit, yeah. Again, if you don't want to graph because you think you're saving time, you will be one of the people that will make stupid mistakes. So, I mean, you know, it's up to you. Where's negative 0.91 roughly? A little bit to the... Yeah, so down here somewhere. Doesn't have to be perfect. And where's the area that I'm talking about? Yeah, it's above. My chart... Now don't get ahead of me. There's a shortcut. But just to do it directly, my chart, if I look up a z-score, it tells me the area below. The graph on top of your chart reminds you of that fact, right? Well, real quick, can somebody tell me, is the answer to this question going to be bigger or smaller than 50%? Bigger. The answer to this question will be bigger because there's half above 0, and I'm including a little bit more. So if your answer at the end is 0.4 something, you screwed up, right? Okay. So let's look up negative 0.91. What do you get when you look up negative 0.91? Negative 0.9. Here's what really sucks. This is 0. This is 1. So be really careful, right? You guys see what I'm saying? It's so easy to go negative 0.91. There, no, 1 is right there. 1814. You with me? Where is that on the picture? 1814. Below. So the minute you look up a z-score, you just put that sucker below there. What was it, Jeff? I forgot. 1814? Is that what it was? Okay. So then what do you do to get the actual answer to the question? From, holy shit, it's that 1 minus thing, remember? We just answered the opposite of the question. Let's do 1 minus the answer to the question. If that much is 18%, the answer is the rest on the other side. So what is that? So we guys, I don't know if you guys remember the shortcut I showed you earlier. 8, 1, 8, 6. How are we feeling so far? So, yes, sir.
Maybe it's a question, but when it's on the negative side, that's obviously negative 0.1, 8.4.
What does that represent? An area. A negative area would be like a little black hole. Don't be making no black holes in this classroom. You take that shit outside of this universe. Alright? Do that somewhere else. So yeah, that's an area. That's a percent. That's a probability. Can't be negative. Z-scores can be negative all day long. Why is that okay? Because that just means it's Below the mean. It has a meaning then, a physical meaning. It's just below the mean. Look up positive 0.91 for me. Oh, sorry. Okay, look at you. I said don't get ahead of me. Look up positive 0.91. What do you get? It's because the symmetry, right? It's symmetric. So whatever's above negative 0.91 will be equal to what's below positive 0.91. Is that a shortcut? Sure. Does it save you like a ton of time? No. But, you know, it's up to you. If you don't understand it, don't ever use it. It's sort of like blinkers in your car.
So if we did that, that would show work, so we still have to show this.
Yeah, exactly, yeah. But if you use a shortcut, I'm okay with it.
So you'll be fine if we don't show you.
Yeah. All right, there's something else freaky that could happen. We already pretty much tackled this. It's the only other thing that could really happen. What if I had a probability that negative 1.91, like this, 0.55. I like it. Trying to figure that one out. So remember, so we did one like this a minute ago. If I look up 0.55, is that more or less than what the answer is? That's much more, right? Because when I look up 0.55, it's the area below that. It actually theoretically goes forever. But I want to stop where? Negative 1.91. So if I look up 0.55, what area do you guys get? I like it. 0.557088, the gas. So that's going to be all this area. That's too much area. What's this area? Negative 1.91. Whoa. I get 0.281. So then how do I get this area? Track, yeah. So 0.7088 minus 0.0281 is 0.68. That's not 68, is it? It is, really? That's weird. 68 who? 07, right? Good job, John. I'm showing off my amazing skills. Okay. Not too bad, right? Last question before I set you on this handout. Yes?
So for that problem, it was less than negative 0.1 and less than 0.5?
No. That's impossible, right?
Yeah.
Or not impossible, but...
I was
All right. Look, read that. Z is less than 0.55. Read that from the perspective of Z. Z is bigger. If you're looking at it this way, negative 191 is less than Z, which means Z is bigger than that. So Z is bigger than that and smaller than that. Well, that's why the best way to say this is Z is between those things. Because your brain says it's a less than, but see how the variable's on the wrong side.
Yeah, I think
Oh,
that's what
shit.
it was less than.
Yes. Shit. All right, so what if I give you a problem that doesn't have a z-score? Like I tell you, the mean is 41 and the standard deviation is 3.7. I tell you it's normal. And I ask you, what's the probability that x is more than 43? I should be able to do this. It's a normal distribution. All the answers are waiting for me. But what is the title of that thing I just gave you? That chart. I call it the z-score chart. Do I have a z-score? So what's the first step? Make frick a z-score. Actually, the first step would be graph. I like it. There you go. So this is how I do this problem. What goes in the middle of this graph? Not 0. 41. Under that, I can put in parentheses 0, right? What point am I interested in? 43. Where's 43 at?
To the right.
I don't understand why there are people that just sort of put them wherever they want to, and then the picture is not going to help. And then it's greater. So right there, I know the answer is going to be less than. The answer is going to be less than. Well, it's always less than 1 pretty much, but it's going to be less than half, right? It's above the mean and then the area above. So again, it's a quick check. If you get 0.8 something, I'm going to say something like, how do you stuff 80% in that little tiny thing? No. You know it's supposed to be less than half already, if you draw the picture correctly. Now, what do I put under this guy? What do I have to do to figure out what goes under him? I have to make that into a z-score. How do I make that into a z-score? X minus the mean divided by standard deviation. I like it. I don't know. 0.5, 5. 0.54. Why do I always round z-scores to 2 decimal places? Because the chart only goes out to 2 decimal places. Bless you. Now, what's really sucks about z-scores is, sorry, I don't know why, every now and then you have to yell at you. If you don't put a z here for yourself, just do this, you might circle this and goes 54%. Yay, done. No, it's a freaking z-score. You haven't got the percentage yet, right? But doesn't that look like a percent? Like it just is a decimal that wants to be a percent? Oh, it's so evil. Where do I put 0.54 on my picture, though? Where did I put it? Probably in that blank spot, right? So do I know the area yet? No. So you'd either do the shortcut or not. I don't care. So look at 0.54. You get the opposite. Do 1 minus to get what you want. And again, this is that chart is taking the place of us actually calculating the area because we don't know how to calculate areas with curvy tops. So what do you want to look up 0.54? $7,054. So what's 1 minus that? 2946, I like it. So if you look up negative 0.54, you would get 0.2946 directly. That's not the most impressive shortcut ever. Okay, so